just put them off to the side and I'll pick them up when you guys are working on homework. Okay, so example 1, you're given the scatter plot. This is a scatter plot. It's just all of the information put on dots, and then sometimes it correlates, and we'll talk about that in the next example, but there's no line, so you don't connect the dots, it's just random dots on a graph. Okay, so you just collect information and plot it on an x and y coordinate. The scatter plot shows the amounts of x in grams of sugar and the number of y calories in 10 smoothies. How many calories are in the smoothie that contains 56 grams of sugar? First of all, what's your x label?
X is sugar.
Label is grams of sugar. What's your y label? Calories. Okay, so looking at A, if you're given 56 grams of sugar, is that your x or your y?
X.
Your x. So I go over to where x is 56, which is in between 50 and 54, right? So I go up. Okay, there's a...
between 54 and 58.
Oh, it is, yeah, sorry. 54 and 58, I'm sorry. So there's that dot that's in between 54 and 58 to represent 56. What is the y value?
270.
So then your answer would be 270 calories. Question? Okay, B is how many grams of sugar are in a smoothie that contain 320 calories? So now am I given the x or the y?
Y.
The y, so I go where 320 calories is.
70.
Okay, and I see what the x is, and the x is
But why is
about
that last box
70.
so big?
They just didn't have a line there. So I would say 70 grams. Okay? And then the last question wants you to kind of generalize the information. So what tends to happen to the number of calories as the number of grams increases?
It also increases.
Which makes sense. So it relatively goes up as the amount of sugar goes up, so it makes sense that the more sugar you add, the more calories you add, right?
Yeah,
It's
it's
not
kind
like
of
a
common
constant
sense, but it's like if this goes up, this goes up.
Yep, most of the time.
Or
Question.
if this goes down, this goes down.
Okay, that's example 1 for you. Example 2. I'm given, you have to tell whether the data shows a positive, negative, or no correlation. So when your dots go in a relatively uphill like we saw on the last one, that would be a positive correlation, right?
Yeah.
And when the dots on a graph relatively go downward, it would be a negative. So then when you have random dots that don't really go in a pattern, it would be called no correlation.
So then A is that one, and then B is that.
So looking at A, do they relatively go up? Do they relatively go down? Or is that kind of random?
It's kind of random.
It's kind of random. So which one would it be? Positive, negative, or no correlation?
No correlation.
You would say no. And if you look at
Absolutely not.
if you look at the labels on this, it says the age and the vehicles owned. So your parents or the person's age based on the number of vehicles they own. So there's not always going to be like a pattern with
Why
that.
isn't there any dots for 3-year-olds?
Okay? So there's not always going to be a pattern because it doesn't mean just because the older I get, the more cars I own. Or
I
the
had
older
7
I
cars
get,
at the age
the
of 3.
less cars I own.
They weren't real cars, but I could
There's
drive
just
them.
no correlation between the two labels. My goodness. Question.
I could
Why
like ramp
really gosh?
Okay. On B, the temperature and Coke sales at a source. Would you guess that there is a correlation between the temperature and Coke sales?
Yes, it goes down.
Yes.
Goes
And
down.
looking at it, it goes down. So which one is it? A negative association. Okay. It would make sense that the warmer, so the X's go by
What if it's in
temperature.
Alaska?
The warmer it gets, the less Coke sales they're gonna make, right?
Isn't
Because
it
you don't
cool
need
that
it.
like your hair grows faster in the summer?
I'm not a scientist. I don't know that. That'd be a great
But you went to college.
experiment. But I didn't research hair growth.
I don't know why.
All right. This is the last example I have for you, people.
Wow.
That's insane.
Yes. Okay. The table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation. So this time we have to write an equation that models the DVD sales as a function of the number of weeks it's released. Interpret the slope and y-intercept of the line of fit.
Yeah, I know how to do this.
Okay, so the first thing, this is going to take some of the pieces that we've already done and add it into what we just talked about. So I have to write an equation, and it needs to be a linear equation. So which type of equation am I going to write it in?
mx plus b.
Y equals mx plus b because it has to be a linear.
Yeah, and on that top one is +1.
Okay, so hold on. So we're actually going to use our slope formula because it won't always work out that way. So I don't want to teach it that way just because it doesn't always work nicely. So, and this one, in this case, it actually doesn't either.
Yeah.
So we have to use our slope formula, y2 minus y1
x2
over x2 minus x1. So if I say 1 would be x1, 2 would actually be x2 because those are my x's. Then down here are my y's. So y1,
But it don't have a constant rate of change.
y2. It does
It
though.
has like a close.
It does have a constant rate of change. So y2 is what?
It goes 2, 1, 2.
15.
Minus y1
19.
over x2
I2. I think.
2 minus
minus
1.
x1, which is
1.
1. It's just not proportional. It does have a constant rate of change. It's not proportional though. 15 minus 19 is
Negative 4.
2 minus 1.
1.
Okay, so our slope is negative 4. And then how are we going to, what's the y-intercept?
We're just
Then you, we do the y minus y1 equals negative 4x minus.
So we have to write it as y minus y1 equals mx minus x1. So y minus, what's y1?
15.
15.
Let's go with 19.
19.
Equals, my slope is
Negative 4.
parentheses x minus
1.
1.
That's what I was.
What would I do first to get it into slope intercept form?
Distribute.
Negative 4x.
So negative 4x
Plus 4.
plus 4 equals
You gotta
y minus.
Add a beautiful 19.
Plus 19 to
Add 19. So I get y equals.
negative 4x plus 23.
Okay. So now we have it into slope intercept form.
Now we know the y.
Since it's a function, okay, they want you to write it as f of x equals negative 4x
You
plus
could have just
23.
added 4.
I still don't see how it has a
Added
constant
4 to
rate of
the 1
change though.
because x would be 0.
What?
Like you could have added 4 to 19 because that's the slope.
Yep.
Oh, the slope is negative 4 though.
Yes. So we had to find the slope because it goes down, right? Okay. So now we're not done yet though because we have to interpret the slope and the y-intercept of the line of fit. So this is the equation that I would use for the line of best fit.
Like
Okay.
f of x.
I can interpret the y-intercept.
Okay, I just want to give it 1 second. Okay, so when we are interpreting, first of all, for slope, it's the change in what over the change in what?
Change in y over the change in
Change in y over the change in x. Therefore, I put my y label on top and my x label on bottom. What is the y label?
23.
23.
Label. What is the y label?
Million.
Sales in millions. So I put sales in millions. And then what is the x label?
Week.
The week. So we found my slope to be negative 4 over 1, right? So this is saying, is it going to, since it's a negative, do the sales go up or down?
Down.
Wait, it goes down like 4 million per week.
It goes exactly what the interpretation is. It decreases, so the sales decrease $4 million
A week.
in 1 week.
Like if you,
Okay.
Could you put a week?
In 1 week, same thing. Okay, now I need you to listen, please. I am recording because I do have some students gone. So when we are talking about it decreases $4 million per 1 week, it kind of makes sense in the context of our story problem because we're talking about DVDs. So it's saying like when that DVD first comes out, a lot of people buy it, right?
Yeah,
And then
slowly,
as time goes on, people slowly, they either have it and don't want to buy two, or it kind of runs out of the newest thing,
but
right?
I couldn't see how that'd be in weeks.
Well, it's over like the United States. It's not like just Central City. It's like over the United States. Okay. Now, that's just interpreting the slope. So we've decreased $4 million of sales in 1 week. The y-intercept, what is our y-intercept?
23.
And Kit, what does that represent?
Well, it's saying that like as soon as it's released, that's how many like millions of sales.
Exactly. So the day it's released, so day 0, we have $23 million in sales. That's the initial day, the initial sales that we have. And then after that, each week it decreases by $4
So
million.
actually, technically,
sucks.
week 1 is actually week 2. Or is
Initial
that
day.
just a
Initial day is 0, and it's $23 million
Like
that
if the
day.
song got released
1 week later, it went down 4.
so?
1 week later, it went down 4.
Okay.
Now, a lot of you were saying, okay, if you look at this chart, it's not a constant rate of change. And the table is not a constant rate of change because we are doing scatter plots.
So it's not gonna be.
So remember, scatter plots do not get connected with dots or connected with lines, right? So these are just like random pieces of information that we plot, and now we create a line of best fit using the slope that we found. Okay, so when it's approximate line of best fit, it's not necessarily exact. Questions about that?
Do we have to write that flat, the negative 4 over 1?
You have to interpret because it says to interpret. That's part of the pieces. Okay, that is all your homework, or that is all the examples I have for today.
Let me keep that up.